Good afternoon, everyone. Can you hear me? Okay, ma'am. Good afternoon. So, yes, let's begin today's session. Actually, we are left over with only two basics, last two concepts, and then we'll have the revision of total third unit and we'll wind up the unit 3 today. So, okay, all of you look at the screen. So, the next concept is pure virtual function. So, see here, in the previous class we came across what is meant by virtual function and everything, and how we'll be performing static and dynamic binding, and how we are going to perform dynamic binding using virtual function, and then using pointer and reference variables. Yes, and we have gone through the various examples related to that. So now you know about the virtual function. Now, what is pure virtual function and why you require that? Okay, before we get into this theory part, first you see this figure. Suppose I would like to draw the different figures like triangle, quadrilateral, ellipse, circle. So already, suppose if you are going to represent a figure in this manner, this you are going to call it as a hierarchy. Yes or no? Now I would like to have diagrams for these particular figures, but what are the common features we are going to place within the high level of classes? So now triangle and quadrilateral are divided into as classified as polygon, and ellipse, circle you are going to define as a closed conics. And these two you are going to define as a shape. So shape you are calling it as a base class, and I would like to draw different types of shapes. So before you getting into the classified these many things, so first I would like to have a shape as my base class which contains draw as a method. So suppose if I am defining a shape as a class and in that draw as a method, without knowing a type and without knowing specific type or specifications of a particular figure, can we have the functionality of the draw method? You can't. So no. Suppose if I would like to have a triangle, then base draw a figure. And if I would like to draw a circle, based upon the properties or the values given for the circle, I can draw a circle. But if I am creating just a shape as a class and having a method draw, I cannot define a functionality for my draw method, which is just like an arbitrary. Just I would like to, we are giving some definition that in future I may require some draw method, and later based upon the classified or more specification of the classes, I can find the function. So at that particular time, I should have a provision where I can just define a method without. So are you clear? There should be a provision where you cannot define the functionality of the method. Just I would like to define a method. That means future I should write the functionality of this method, and you should be able to override that function based upon the requirement in next level of your derived classes. So at that particular point of time, I can have my virtual function as a pure virtual function. Let's go into the depth. Now see here. Now what is pure virtual function? See, we have suppose I can define my draw as a virtual function. That means first, if you see this particular figure, in shape I can have the draw method. In next level, I can define the polygon. So here I may have the functionality for my draw, that means body for my draw, or here also I may define the functionality, that means I can write the body for my polygon, or I can just keep that method as it is, and in next level triangle I can have the functionality for my triangle based upon the values provided. Okay, that means just I am defining the definition for the method, and later on based upon the requirement I am going to override that method in my derived classes. So that is possible generally with the help of the pure virtual function. Now see here, what is that? I cannot define the root shape class as we do not have an algorithm to draw an arbitrary share. So that's what I explained you. Suppose if you don't have any particular values for my draw, can we define the functionality of my draw method? No. So at that particular point of time, I can define my virtual function as a pure virtual function which can have only a signature but not body. That means just I am having the definition of the function without writing the body. So now how we are going to define the pure virtual function? See here. We are going to define pure virtual function. So what is the definition? See, this is the way how we are going to define virtual function. Yes or no? Virtual, suppose boy. If I am defining like this method you call it as a virtual function. Now if I would like to make this method as pure virtual function, just assign it to 0. Keep a semicolon. Then it acts as a pure virtual function. Okay. Now are you clear up to here? Just we will mention that if you want to write there, then we can define a virtual function as a pure virtual function. Okay. Then what you have to do? In the derived class, we must be able to override the pure virtual function in your derived classes. Okay. Suppose. Now see here, let's go into let me explain the example, then I will give the conclusion part. Now look at here. All of you look at here. See here, I am having a class base. Okay. In this, This is a pure virtual function. Okay. Virtual void fun equal to 0. I can have my constructors also in my abstract class. Or one more thing, what is an abstract class, what is a pure virtual function, just within a minute I'll explain you. Now what is pure virtual function? This is nothing but a pure virtual function. Now a class which is having a pure virtual function, that you call it as an abstract class. Okay, an abstract class consists of at least one pure virtual function. What is pure virtual function? A virtual function which is assigned equal to 0, that you call it as a pure virtual function. Okay, so if any class that at least one pure virtual function, then you call this class as an abstract class. Okay, then you call this class as an abstract class. Suppose what an abstract class can consist of, it can contain pure virtual functions or normal functions, and you can have the constructors also. Okay, now coming to the derived class. Now you are having pure virtual function. This must be overridden in your derived class. Yes or no? Now define a class derived. It can have the own constructor, and in this derived class I am trying to override my function method which is defined in my base class. Here I am writing the functionality of that particular function. Okay, suppose now, are you clear? Are you following, guys? Are you there? Yes. Yeah, I will repeat. I will give the conclusion. Don't worry. Just go with this example, then I will explain the theory. Right? Let's read it. Just go with this example, then I will explain everything. Okay? Now, see here. Now, once you are having the base, up to here, I hope it's clear. You are defining a base class. In this, we are having a pure virtual function. How you will be knowing it's a pure virtual function? When I don't know what I have to define within the body of your method, then I can go for my pure virtual function. That means in virtual, I am unaware of what to define in the body. Then I can have my pure virtual function, and later on in the derived classes I can define the body for my pure virtual function by overriding them. Okay, now I hope up to this it must be clear. It means that I override this method. Okay, now suppose, are you following? Now suppose in this level also, in this level, that means I am having the derived class. In this also, if I am not having this method, that means if this method is not there, if I am not overriding this function method in this, then this class is abstract. Okay, it will get inherited to this particular class, but here also I am not able to define the functionality of my function method. Then this class or also acts as an abstract class. Then later on, in the next level, I can define my function. Sorry, 1 minute. Derived, right? So one more class. Let me take one more class. Public derived. Suppose in next level, here instead of writing the functionality in this particular method, I would like to define the functionality in this method. Okay, so in this class, then the previous class acts as a acts as an abstract class. Not it has to be overridden in the next level itself. So based upon where you can define the actual functionality, there you can override the method. Till that point of time, if the method is not, suppose if a function is being inherited or being derived, suppose if you are, suppose, 1 minute, let me create one more thing. Now see here, suppose, only two things you have to remember. Suppose, now using one, what is an abstract class now? It contains pure virtual method, okay? Pure virtual method. It contains pure virtual method. So, in derived class, you need to override. Okay, what an abstract class contains? It contains pure virtual methods or normal virtual methods. Or you can have normal methods. You can have or anything. Okay. Now, what you can do in the next level in derived class, you should be override these abstract methods, these pure virtual methods. Okay, you should be able to override pure virtual method. Okay, suppose in next level, if I am trying to override pure virtual method, then terminate my object for my derived class, and I can access all the properties of my abstract class. Okay, that might be either variables or methods or constructors. You can have the variables as well. Okay. Now, suppose if in derived class, in next level, okay? In next level, if I am not overriding, this is not, you are not doing it, okay? Suppose if you are not doing it, then I am going to override in next level, okay? Derived class, next level, okay? In next level. Suppose this you take it as a derived class 1. Here I am taking it as a derived class 2. Here I am not doing overriding. And just I am writing my own functionality. That means I can have my methods, variables, and constructors here are the same things. Okay. And in next level, suppose instead of overriding here, I am trying to override here. Okay. Now, listen. Now what happens? This is being abstract class. Yes, abstract class is being inherited. Now this class also will become abstract class, because as these methods are being inherited here and we are not overriding in this particular class, then this class was also called as an abstract class. Are you following? Are you following, guys? Okay. Now, in the next level, derived class, now what I am doing? I am trying to override all the pure virtual methods. Okay, suppose it might be either 1 or 2. Whatever the pure virtual methods, that means a class which should not have pure virtual methods either by inheritance or by defining within that particular class itself, then you call it as a normal concrete class, or you can call normal class. Yeah, what is the need of abstract class? Means if I am unable to define the functionality of a method, then I can have a pure virtual method. Suppose if in a class one pure virtual method is there, then you define that class. Clear? Suppose if the functionality of a virtual method, if I am unable to define, then I can define that method as a pure virtual method. Okay, and if in a class at least one pure virtual method is present by inheritance or by defining within that class, then you call that class as an abstract. Okay, this is the overview, whatever we have discussed till now. Is it fine? And also having doubts. What I created now. So now now let's have the theory part. So you can record in there. Now, how you will define the pure virtual method equal to 0. Okay, if you are defining virtual function equal to 0, then it will be defined as considered as a pure virtual function. And you must implement all pure virtual functions in derived class. Okay. Now, if we do not override the pure virtual function in derived class, then the derived class also becomes abstract class. Just now I explained you. Okay. Pure virtual function is also known as abstract function. So other name for that. Okay. A class with at least one pure virtual function or abstract function is called abstract class. Just now I gave you the definition. So one more thing. We cannot create an object for your abstract class. Okay, for abstract class, you cannot create an object. Okay, now how you can access the members of your abstract class? By creating the object for your derived class. Through that, you can access the members of your abstract class. Okay, and it can have the constructors as well. Okay, now this example just now I told you. That means using this by creating, let me delete this guys. So see here, that means just now I told you, by creating an object for your derived class, I get the members of your abstract class. Okay. So I hope you know with the concept of constructors, right? What is there here? I am creating an object for my derived class. Derived D 4,5. So come here. It will call the parameter as a constructor derived in type int J. Now explicitly I am calling the base class constructor. So I will be passed to your base class. Now x equal to I will be assigned, and then here y equal to j will be assigned. Now I just try to print the values x and y in the function. Okay, this will get executed. Okay. Now, here is the total key points regarding the abstract base class. You can study. A class containing at least one pure virtual function is called an abstract base class. Okay. Pure virtual. Hope you are following. And after reading this, if you are having any doubt, let me know. Okay, no instance can be a base class. What it indicates, we cannot create an object for your abstract class. Okay, and one more thing, as we cannot create an object for your abstract class, it will not have by default constructor or destructor. Okay, explicitly we can create constructor or destructor in your abstract class, but by default the compiler will not create any constructor or destructor for your abstract class, as we are not having an object for your abstract class. Okay, now one more thing, next one. We can virtual member functions as well as data members. That means any type of methods can be defined in your abstract base class. Okay, and you can have the access specifiers also, like public, private. Based upon that, you can restrict the accessibility of that. Okay, and just now I told you a concrete class. What do you mean by concrete class? Normal class, the derived class, you can call it as a concrete class. There you must be override and implement all pure virtual functions so that it can be instantiated. That means when you can create an object for your derived class, then it does not contain pure virtual functions either by inheriting or having or defined by its own. Then you can create an object for your class. This is about the abstract base class and pure virtual functions. Both concepts are interrelated to each other. I'll give you a minute, just go through it. And let me know if you are having any queries. Please post it in the chat box so that I will clear you. Completed? Any doubts? Let me know. Harshita, if we do deriving the pure virtual function in derived class, then there will be one abstract class or two. If defining the pure virtual function in derived class, then derived class will also act as a abstract class. There will be one more class which will be overriding the pure virtual function. Okay. Okay. Can you explain the declaration of virtual class? Okay. See here. This is what. Okay. Look at the example, guys. Now we are having abstract class. Abstract class means if you are having a pure virtual method, then you call it as an abstract class. Okay. Now how you will be knowing whether it's a pure virtual function? If it is assigned with equal to 0. Okay. Now then you call it as a pure virtual method. Now class base protected, you can have your pure virtual method and you can have the constructors. It's just for example I gave it. Okay, you can leave this if you don't. Then in derived class, which inherits base, in the derived class what I am doing, I am trying to override this pure virtual method. Okay, That means void function. Here I try to write some functionality. Then this class you call it as a concrete class. Okay, this class you call it as a concrete class, which overrides pure virtual method. So it is overriding pure virtual method. So it's not this class is not an abstract class. Okay, suppose so many scenarios you can have, guys. So at this level what I'm doing, I'm trying to override this, and along with that, suppose if this function is not overriding here, this class acts as an abstract class itself. Siddharth, are you following? This function is not overriding here, then this class also it acts as an abstract class. So there should be one more derived class which will override this pure virtual function. If you will not define or if you will not override pure virtual function, what it will happen? You cannot create an object for your abstract classes, so that you can't access the members of it. Is it clear? So in order to perform the functionality in a proper order, a derived class must be override all the pure virtual functions, so that you can create an object for your derived class and access the members of your abstract class, and as well as the concrete class, derived class, whatever you are defining. Is it clear? Virtual class, this is the definition, that's all. Any more doubts? Let me know, guys. Any more? No. Okay, let me move on. Last concept, virtual destructors. Now, virtual destructor. Now here you can see, let's go with the example. Then I'll give you the conclusion. Now, you might be Arshita, what is that? Ma'am, can we define? Yeah, that's what we did, no, Harshita? Can we define pure virtual function in base class? Yes, that's what we did find. There is this example. In base class itself, we define the pure virtual method. According to your question. In derived class, we will override. Now see here. Virtual destructors. Now virtual destructors? What do you mean by virtual destructor? Generally, suppose if you see here, in the previous classes we came across the upcasting. What do you mean by upcasting? Suppose if you are having a virtual method, suppose base class reference. Now if you see here, in this main, base star b equal to new derived. That means what it will happen? Base class reference is being referred to your derived class object. Yes. No. Base class reference is pointing to the derived class object. Then what it will happen? First, it will create. It will check. It will check what it will do. Suppose if you are having two methods within the base class as well as in derived class, then what it will do? Same methods. Yesterday, in the previous class we have seen, guys. Let me go with that. So see here, if you are having the same method in base class and derived class, and if you are having a virtual, then what you are going to do, base b equal to ampersand b, the same one there. Okay, now what you are going to do, then if f is present in your derived class, then what it will do, it will override it will call the method of your derived class. And suppose in the same way, in which order the constructors will get called? When you work with constructors and destructors, let's pause. Suppose if you work with your constructors and destructors, what will be the order of constructors will get called? First base class constructor will get called and then followed by the derived class. Yes or no, generally. Now, here when you are creating a reference for your reference for your base class, then what it will do, it will call only the base class destructor. It will not access the derived class destructor. Okay, as reference is provided for your base class, then only the base class destructor will get called. Okay, just it's regarding the destructors as we are talking about. So base star b equal to new derived. Now you are creating or you are accessing the reference with respect to the base class. Then when you write it as delete b, then only base class destructor will get called. But in order to delete or in order to remove the memory properly, then what you have to do, first derived class destructor should be called first, then followed by the base class destructor. Yes or no? When we discussed about the constructors, there will be the order of execution of your constructors and destructors. Constructors will be executed in a forward order, like base class constructor will be called first and then followed by the derived class constructor. Coming to the destructors, first derived class destructor should be called first, followed by the base class destructor. So here also the same. Now, as we are going for the upcasting, now if you are calling with your derived class object, what I am doing, I am using the base class reference for your derived class object. So problem, only the base class destructor will get called. Derived class destructor will not get called. So proper whatever the memory it has been constructed, it cannot be destroyed properly and it which results in your memory leak. So what you will be doing here, we will make this as a virtual. Base class destructor as a virtual. Now you can see in the next example, this base class destructor we will make it as a virtual. Now what is the use of a virtual method in the previous classes? Suppose when you see this method as virtual, you will go for your derived class. Here you will see whether anything, suppose instead of constructor, suppose if you are having a method, virtual method, then what method is there in your derived class, first you will execute that method and come back, yes or no. In the same way, if it is with destructor, then what it will do? Virtual destructor. So it will execute the derived class destructor and then execute the base class destructor. Okay, so that memory will be released properly. So now I can let me show you the execution. One minute. See, actually this example we try to do virtual destructor, right? See here, generally if it is not with this virtual, and we try to do generally with your derived class. When we have a derived class object, I will create the constructors also for you people for understanding. Then now see here base B. Okay, let me execute this. So generally when you create an object for your what is wrong? Yeah, header files. I hope. Okay, see here. Okay, see Yama, let me keep end line. So generally, once observe guys, when we create class, what is the way it will get called? First constructors base and derived, then followed by derived destructor and followed by the base destructor. But here the scenario is different. What I am doing, instead of creating my derived class reference for derived class object, what I am doing, I am creating, see the line number 32. I am creating my object base class reference for your derived class object. So what it will do? Here is the difference. Are you observing? Here is a difference. When I create my base class reference for your derived class object, now how it has to be destructed. Constructors are called properly. First derived destructor has to be called, then followed by the base destructor. But derived destructor is not getting called. Okay. So for that purpose, what we have to do? We are introducing a concept called as virtual destructor. Okay. Using that, we can call a method. So using that, what we can do? First, we can call the derived class destructor followed by the base destructor. So here you will include a keyword called as virtual in your base class destructor, so that you have to get the same output. Are we getting the same? Just for in order to avoid the memory leak, we are going for the derived destructor concept. Is it okay? And remaining everything is same. Just this is a concept for your derived destructor. Sorry, not derived destructor. What is this? Virtual destructor. So now you can this class can be virtual. Whenever upcasting is done, destructors of the base class must be made virtual for proper destruction of object when program exit. What is memory leak? Suppose, what do you mean by memory leak? Now, one thing, ma'am. Suppose now when you execute a program, what it will happen? Memory will be allocated for variables, methods, and so on. Then, when you stop executing the program, then that memory has to be released in order to make provides for the other programs to execute. Then, if then it should be executed, or the compiler, generally the compiler will take care of the memory release. Now, suppose if you are using either pointers. If you are using either pointers, then what it will happen using dynamic memory allocation, then it is our responsibility to delete the memory. That means using pointers, sometimes we try to allocate memory for my variables or objects. Then it is our responsibility to release the memory. If you are not release the memory, then it a problem called as memory leak. That means we are not able to the object or that memory we are no longer we are using it, but still the memory has been occupied by our program. Okay, which cannot be useful for the other purposes. That scenario you call it as a memory leak. Okay, so in order to avoid that, so here we are trying to delete the memory using the delete keyword. So when you use the pointers, it is our responsibility to delete. So I think in the first unit we came, it was new and delete concept. There you will be learning about memory leak. Is it clear? So that's all. Let me know any doubts. For all of you guys, those who are present, any doubts regarding anything? So let's have the revision. I'm just moving on. I mean, this is the last concept, the total unit. I mean, reason in the sense I will not explain each and every concept in detail, just like we did in the class with a number of examples. I will just do the overview, what is what. Okay. Now, all of you concentrate. What I will do, I will just explain you using these topics itself, and let me know if you are having any doubt regarding any topic. Then I will enter into the topic and give just overview of that in detail. Okay. Now all of you please concentrate. Now the first part, you are having inheritance. Okay. What is inheritance? That means first, in this you are having several topics like class hierarchy, different forms of inheritance, base derived, accessing to base class members, base and derived class constructions, destructors, virtual base class. So everything. Now what do you mean by class hierarchy? Now what do you mean by class hierarchy? How you define a class hierarchy? In the beginning stage itself, I told you how you define an inheritance, that means base class, derived class, how you define the level of your classes, that you call it as a class hierarchy. That means the more common going in base class and specializer ones you are going to define within the derived classes. So when you see here, only one example, I'll explain you. Suppose if you are having an employee, suppose faculty, administrators, office assistants, technical staff. Here you might be having different set of people. Each and every people commonly you can call it as an employee, and each will be having a common set of properties like employee ID, designation, and so on. These common properties I am going to group together and place it in a one common class. We call it as a base class. Base class. And other specializer ones like faculty, admin, office, technical. Okay, this derived class. Now, how we are going to place this hierarchy of classes like base class, then followed by the derived classes? You call it as class hierarchy. So why you require this particular feature is nothing but, now instead of replicating the member functions in each and every classes, suppose the same common functionality should be represented in each and every class. Instead of writing each and every class, what I am doing, I am going to place it in only one class. I am going to inherit in several different things. So, in order to avoid the replication, I am going for a class hierarchy feature, and this is possible with inheritance. Okay, now next see here, what is inheritance actually? Different forms of inheritance before going into is, what is inheritance? Defining, you are having two different classes. Inheriting the base class properties in your derived class, you call it as an inheritance. Now what is meant by base class? Suppose if you are having a shape, I told you, suppose here I can have staff. Suppose I can have teaching staff or anybody. Now what I can do here, this you call it as a base class and this you call it as a derived class. Now, or you can call it as a super class or subclass. Base class or super class, subclass, derived class, you call it as an inheritance. Okay, these properties I am going to use here. This particular feature you call it as an inheritance. Now, different forms of inheritance. How many forms of inheritance you are having? These are the 5 forms of inheritance you are having. Single, hierarchical, multi-level, hybrid, multiple. Single level means only one superclass, one subclass. Hierarchical means one base class followed by the 3 subclasses. 3 subclasses have one. This is only a 3 we took. Multi-level. Multi-level means you can have, that means this is a base class and this is a derived class for this base class, and next this is one more derived class, and this is a, now for this is a base class and this is also a base class. That means here you can have multi-levels. Now hybrid inheritance. Hybrid inheritance is nothing but which is a combination of 2 or more types of inheritances. You call it as a hybrid inheritance. Okay. In this you can see, in this part if you observe, it's an example of multi-level. If you see up to here, it's an example of hierarchical. If you consider the lower part, it's nothing but multi-level. That means it's a combination of 2 or more types of inheritances. And next, multiple. Multiple is nothing but if you try to derive a derived class from 2 or more base classes, then you call it as a multiple inheritance. Okay. Now see here how you define base class and derived classes. Then access to the base class members. Now see here how you define base and derived class. Now this is a definition. Now class base, suppose instead of class A, I can define it as a class base. I can have my own functionality here, that means variables and methods I can define. And in derived class, with the help of access specifiers, what are the access specifiers I'm having? Public, private, protected, and here I should inherit base. Okay, so that base class members can, that means derived class will have base class members. Along with that, we will be having its own set of members. Okay, this is the way how we will define your base and derived class. You are having now access to your base class members. So here comes, so how much is in the base class members. Now based upon the access specifiers, you will be knowing how you are able to access the base class members. That means you can see in the base class I might be having either public, private, private data. Inheriting, that means just now I gave you the syntax. What is the syntax? Class derived access specifier. Here I can specify either, suppose according to this figure, first I am placing public. If I am placing public, then this public data will be accessed public in derived class. If it is protected, it will be accessed protected itself. And if it is private, then private data cannot be accessed in your derived class. Okay. Then here in this place, instead of access specifier, if I place protected, then what it will happen? This public will become protected. This protected will access protected itself. Private data will not access in your derived class. Okay. In the place of protected there, then this public will become private. Protected will become private. Private will no longer access. Now, what is the difference between public, protected and private? Public, if you define a data as public, or if you try to access using public, then or outside the classes as well. That means you can access the data throughout the program. If you can define throughout the program. If you are defining it as protected, the data can be accessed only in your derived classes. Other than that, they act as a private data. That means suppose if I try to access within a mail, then it acts as a private data. Suppose if I am defining it as a private, then that data can be accessed only within that class itself. Outside the class, you cannot access. So that is about different access specifiers, how you can access the base class members. That means based upon the restrictions or based upon the visibility provided, you can be able to access within the next level of your derived classes. Okay, already we have seen with lot of examples in the previous classes. Now, yes, base class, base and derived class construction. Now, what is in the construction? Now I am having the base class and derived class. Now, when I create my object for my derived class, what is the order of construction? Yeah, can you give the answer? I'm having the base class. Let me show you the diagram. Syntax. So let's take this simple skeleton. Suppose if I am creating an object for my derived class. Okay. Derived class. Then what it will happen? Which class will be constructed first? Suppose if I am creating an object from my derived class which inherits base class, then which class will be first? Just now I showed you guys. Yeah. Yes, good, Ganesh. When I create an object for your derived class, now what is the scenario? How the derived class will be constructed? Derived class consists of base class members followed by the derived members. Yes or no? So, I create my object from my derived class. Then what it will happen? It will come here to this line. Here what you are having, you are inheriting the base class. So first the base class will be constructed, then followed by your derived class. Okay, not directly the derived class. Suppose if I am creating an object for your base class, then do you have any inheritance? So directly if I am creating an object for your base class. Now if I create my object for your derived class, then base class will be constructed first, then followed by the derived class. Okay? Just now I showed you the execution also. Yes? Now destructors. What about the destructors? How the destructors will be called? How the destructors will be called? The same for the same. I am creating my object for your derived class. First driver, then followed by base. Yes. That's what. Okay, generally why you required a destructor? Generally when you would like to destroy the object, you will go for a destructors. Okay, it will be called during the end of the program whenever the unused things are there in your program, and when you are not destructed. Destructor take care of deleting them. Okay, then virtual base. What is virtual base class? Can anybody give me what is the definition of virtual base class? What is the use of that? Any definitions? So you can come here. So this is virtual base class. Now, just now I told you, if the base class I try to access from, Ganesh give me, helps in data redundancy when the same class is got derived from multiple. Yeah, he gave his definition in his own words. Good. Now generally, this base class I try to derive from multiple paths. then it as well as from the part C. Then there exists two duplicates of your A class. Then in order to avoid the I'm going to inherit this base class as your virtual base class. Then only to your D. Okay, that is the functionality of your virtual base class. In order to avoid the ambiguity when multiple sets, then you are going to define that class as your virtual base class while you are inheriting. Okay, so this concept you call it as a virtual base class. So how you will write it? So I'm not explaining the total. Inheriting, you can see figure A, it inherits B and C. So while inheriting this, you will proceed with your virtual keyword. So what you are doing here, I'm proceeding with, instead of writing just public A in order to inherit, I am proceeding with the virtual keyword, virtual public A, class C, virtual public A. Okay, so that only one copy will be transferred to your class D when you try to inherit B and C. Okay. Now, you are having virtual functions and polymorphism. You are having static and dynamic binding, virtual functions, dynamic binding through virtual functions. Virtual function call mechanism. See, these are all the concepts, each and everything are interrelated to each other. So, static and dynamic binding. What is meant by static and dynamic binding? What is static binding, guys? When you try to bind method during compile time, then you call it as a static binding. When the decision is retained till runtime, then you can go with your dynamic binding. So dynamic binding, you are going to make it possible with the help of virtual functions, with the reference variables. Okay, hope you remember. So normally whatever the normal programs still you learned before this concept, that comes under the static binding itself. And next, dynamic binding plays a major role with the help of combination of virtual functions and pointers or reference variables. Okay, that means the decision of the method, that means when you call a method, the decision will be kept pending until runtime. Now, so you can see here, function invocation binds to a function definition based on static type of objects across these definitions. So now what the static binding happens if you are not, if the method is not virtual, then it undergoes static binding. Now you can see here, base class pointer is p equal to, already we came across this example, so I am directly going into your step. Base class reference to your derived class object, p of f, that means I am calling the method f. As this f is non-virtual, then directly only the base class method it is going to call. Okay. Now if this method is virtual, then the same example replicates here. But instead of normal method, we are using the virtual. P equal to ampersand d means it will check in the derived class whether this method has been overridden or not. Yes, in derived class you are having method which is overridden. So the method instead of base class method. When you use a virtual keyword, then it will check in the derived class whether this particular method has been overridden If it is overridden, derived class method will be called. If not, base class method it will be called. So already we came across virtual functions. So dynamic binding is possible for pointer and reference variables, and for member functions, and these I told you. Suppose if dynamic binding is possible with pointer and reference types, and member functions that are declared as virtual in the base class, then those functions you call it as a virtual functions. And as it works in multiple ways, you call it as a polymorphic type. That means, suppose if you are defining it as a virtual, it will call a derived class. If not, it will call the base class. So one function which is acting in multiple ways, so you call it as a polymorphic. Now, just now we came across this hierarchy of shapes. Pure virtual function, just now I told you what is that. Pure virtual function is not able to define the functionality of your virtual function in your base class. Then I can go for your pure virtual function. And if at least your virtual function is there in your class, then that class you call it as an abstract class, and you cannot create an object for your abstract class. Then there should be a derived class where you can override the pure virtual methods in your derived class, so that you can create an object for your concrete classes. So I will define equal to 0, that will represent the pure virtual function. And came across pure virtual methods. And abstract classes, just now I told you, which was nothing but abstract class. Virtual destructors, in order to avoid the memory leaks, in order to have the proper destruction of the object, when program exists, you have to go for the virtual destructors. So here are the total third unit, and let me know any more queries from your side. So once go through the contents and let me know anything you are not clear. Here I can say you each and every concept, these concepts are interrelated to each other up to here. And I gave you so many programmatical examples, but as this is a revision class, I can't brush up all those revision. Are you clear? And 2 days I will forward you the material regarding the third unit totally. Okay, I mean what are the programs are placed on the test later, I will provide you the solution. The respected faculties will forward to you. Let me know guys, is it clear or do you have any doubts? The only thing is you have to go through the total unit from your side. Then you may have few more doubts. Yeah, abstract class, the way, yeah, it's similar to your Java's also, but the way how you will represent here, it's a little different. There you will proceed with your abstract keyword. Yes or no? So here, just if it contains pure virtual method, then you call it as an abstract class. Little changes will be there, and here you don't have like interface. So that is the drawback of your C++, which you are going to overcome in your Java. So multiple inheritance is not supported in your C. This one is one of the flaw. So in order to achieve multiple inheritance through interfaces, there is a difference, Ganesh. In the way how you will overcome the multiple inheritance concept. Any more doubts, guys, from your side? And those who don't have, will enable one program, try to do that. And let me know if you are having any doubts, please post it in the chat box. Yes, meanwhile, if you don't have any doubts, you can go ahead with coding. Virtual base class program. So I think the lab exam, I think last week, you might be having some error. It's a technical issue. So I think now you are able to attempt it. It's resolved. So I hope you can attempt now. Let me know, guys, by the way, any more doubts from the third unit? When you look at the syllabus, it looks like the topics are more, but once if you understand the concept, the unit is very simple. The second part is little logical, as it involves virtual functions, virtual keyword. When it comes, it involves little logical thinking. I think recorded class will be forwarded by. I will let you know. The links will be shared, guys. Generally, I think they are placed in Telegram. I mean, KMIT online itself. PPTs and materials I will be forwarding. Okay, by today or tomorrow. I'll forward the my notes. Anymore? From next week, Unit 4 is going to. I would like to know from. So before the next unit starts, try to complete all the tasks. All the tasks of your Unit 3, which are being enabled till now.